Hello and welcome back to One Day to Get 5 MA for AP Calculus. This is episode 41. Oops. And today I have a problem for you from Unit 3. Alright, so evaluate the cosecant of tangent inverse of 4/3. That is the problem. Alright, so give the problem a try and then just check back and see how you did. Alright, the cosecant of tangent inverse of 4/3. Because cosecant is the reciprocal of cosine, that can be written as 1 over the cosine of the tangent inverse of 4/3. It's generally a lot easier to just memorize the identities for cosine, sine, tangent, and then just use the fact that those are reciprocals of the other, like, cotangent, cosecant, and secant to find the answer that way. So that's what I'm going to be doing, because just for me personally, there's a lot of trigonometric functions, and I just find it easier to work with cosine, sine, and tangent personally. So there's actually an identity for taking the cosine of tangent inverse of some value, right? But and that is the cosine of tangent inverse of x is equal to 1 over the square root of x squared plus 1, or 1 plus x squared, whichever way you want to write. That is the identity, but I want to show that real quick. So imagine that we have a right triangle with an angle theta, and our opposite side from the angle has length x, and the adjacent side is length 1. By the Pythagorean theorem, we know that x squared plus 1 squared is equal to hypotenuse squared, or the length of hypotenuse squared. And the hypotenuse must therefore be the square root of x squared plus 1, and it's going to be positive square root because it's a length, and lengths have to be positive. So it's going to be a square root of x squared plus 1 squared, or sorry, just x squared plus 1. It's redundant. Okay, so if you remember, SOHCAHTOA tangent of theta is equal to the opposite over hypotenuse, so x over 1, which is x. And what this implies is that the measure of angle theta, or I'm just going to write theta actually, the value of angle theta is equal to tangent inverse, and this works because this is an acute triangle, right? There's other formulas. Sorry, this is an acute angle theta because it's inscribed within a triangle. It can't be larger or equal to 90 degrees because it's inside of a triangle. So there's different formulas for angles that are not acute, like between 90 and 180, and between 270 and 360. There's different formulas than between 0 and 90, and then 180 and 270. There's different formulas for those, but since it's an acute angle, we can just say it's a tangent inverse. Anyways, I'm getting way off track. This will mean that theta is tangent inverse of x. And then, if you remember, cosine of theta is going to be the tangent. Sorry, cosine of theta is going to be SOHCAHTOA. SOHCAHTOA. That's SOHCAHTOA, right? So cosine is adjacent over hypotenuse, and the adjacent is 1, and the hypotenuse is square root of x squared plus 1. So that's our thing for cosine of theta. So if we take the cosine of both sides, if we take cosine theta equals cosine of tangent inverse of x, well, this is what we want to find, right? We know that cosine theta is going to be 1 over square root of x squared plus 1. So this is how you find the identity, right? That's exactly what we're looking to find. Oops. So yeah. Alright, so this is going to be 1 over the square root of 4/3 squared plus 1. And because we're taking the reciprocal over reciprocal, it's just going to cancel out to be, the thing that we're taking the reciprocal of. So 4 squared over 3 squared, that's the same thing as 16 over 9, because you can distribute the squared. And then plus 1, which is the same thing as 9 over 9. So this is going to be the square root of 16 plus 9 is 25 over 9, because we have the same denominator, we can add them. And that's the same thing as square root of 25 or square root of 9. The same thing as 5/3. So that is the final answer. I hope that you found the video helpful, and I hope that you have a good rest of your day.